So in this video, I want us to first analyze simplifying these expressions, and this really will help us practice multiplying with imaginary numbers. So here we have two factors that we need to multiply. So this is a type of foiling that we'll do where we'll multiply in the threes. So we'll get, let's see, 3 times 3 is 9. 3 times I gives me a positive 3i. And then if I multiply the negative I over, that's going to give me negative 3i. And negative I times positive I gives me a negative I squared. And so from here, I can see that the two middle terms are opposite signs but same coefficient. So they actually cancel, which is quite nice. So the middle terms cancel. I'm just left with the 9 that comes down. And I have a negative, but this is an I squared. So it turns out that's just a negative 1. And so two negatives make a positive, right? And so I really have a 10. 9 plus 1 is 10. And so I just get a 10, which is kind of nice. I went from all of this to just a simple answer, 10. And so that's kind of weird. And this next one here, notice how they're both the same factors, kind of like these. These are both the same factors, only one's negative and one's positive. And same here, one's negative, one's positive. So I want us to notice this pattern, but I'm going to go ahead and FOIL like normal. So 4 times 4 is 16. 4 times positive 5i is positive 20i. And then if I take the negative 5i, that gives me negative 20i when I multiply by the 4, and negative 5i times positive 5i is negative 25i squared. The 5 times 5 gives me 25, I times I gives me I squared. And so again, the middle terms are opposite signs, so positive and negative, and they're both 20s. They're the same coefficient, so they cancel. So all I'm left with is 16 minus 25, and I have an I square here, so that makes it a negative 1 that it transforms into or can be replaced by. And so I really have 16 plus 25 because negative 1 times a negative 25 makes a positive. So 16 plus 25 gives me 41. So again, I get a nice clean answer at the end after I FOIL that imaginary numbers, those two factors with imaginary numbers. So one of the things that I notice is that after I FOIL the factors, the middle terms always seem to cancel out. And this has to do that they are the same factors, but opposite signs. So that's why the middle terms always get to cancel out. And then because I'm always multiplying the i's with the other I get that I squared. And I squared is a nice number. It always ends up being this negative 1 value. And so what I can write here is after the factors are FOILed or multiplied, the middle terms always cancel. And this is significant. Why do I care about the middle terms canceling out? Well, because the middle terms is the one that has just I to the first power. If the i's can cancel out, that means I'm back to real numbers. Both of these were real answers at the end. So sometimes, even though we have imaginary components or imaginary numbers, it doesn't mean that our final answer will be an imaginary number. Sometimes it can go back to being a real number. And that's why imaginary numbers are significant to mathematics, because they can help us get back to real values or real numbers. All right, let's get into what it means to be a conjugate. And conjugates are really helpful when it comes to dividing things that have imaginary numbers. Like these here look like division because it kind of looks like a fraction, but fractions we've learned that it's just another way of expressing division. But what we need is conjugates to help us out. So a conjugate is basically a change of the sign. And I'll explain what I mean. So when I think about a conjugate, it's where we change the sign in the middle. And what that is referring to is, notice how like these problems here, they're actually conjugates of each other because they're the same factor, but the signs in the middle are switched or changed. And so what that is saying that if I have a number, let's say a plus some imaginary number, but I'm adding the conjugate to this. Conjugate would just be a minus bi. Or you can also say that this minus is the conjugate to the plus sign. So essentially what conjugates are they're factors that are different opposite signs. So why do we use conjugates? Well, it's because conjugates help us get rid of imaginary numbers. So I want you to take a look at this problem here. When it comes to dividing, you don't divide like you normally would, where you try to decrease, try to take the top and divide it with the bottom. It's not going to happen. It's just too difficult. It's actually impossible. So in this case, what we're going to do is we're going to multiply by the conjugate. And so we always take the look at the bottom. So always look in the denominator. And one of the most difficult part about imaginary numbers is that you can't divide by imaginary numbers. Truly is very difficult to do, or impossible to do. And so what we do instead is we try to get rid of it. And to do that, we'll multiply, we'll take the bottom, and the conjugate to the bottom is 3 minus 5i. So if I multiply the bottom by its conjugate, that will help relieve the imaginary numbers in the denominator. But that means I have to multiply it to the numerator as well, because anything I do to the denominator, I have to do it to the numerator as well. So if I'm multiplying the denominator by this conjugate, I have to multiply by the same conjugate to the numerator. So what we do is we focus always on the denominator first and find the conjugate for the denominator, because that is the thing we want to divide. And so we can't divide by imaginary numbers, so we're going to multiply by the same conjugate to get rid of it, the imaginary numbers. So when I'm setting it up, I always take the denominator, find the conjugate, so I switch the signs in the middle, and I multiply the top by the same conjugate. From here, it's a matter of just knowing how to multiply and FOIL. So I'm going to show you. If I have the top here, negative 2i, I'm going to multiply that into just straight across. So I'm going to multiply the negative 2i to the 3. So that gives me negative 6i. Negative 2 times negative 5 gives me positive 10. But the 2 i's multiplied gives me an I squared. So I'm done with the top part. I'll clean it up later. But now I'm going to FOIL at the bottom. The foiling out the bottom is a little bit tricky. So I have 3 times 3, which is 9. 3 times negative 5 is 15i. 5i times 3 gives me positive 15i. And then the 5 times negative 5 is negative 25i squared, because there are 2 i's here. I want you to notice, because we multiply by the conjugate, the middle terms are opposite signs and they're the same coefficient, so they're going to cancel, which is kind of nice. The top term here has an I squared, so I can change that to a negative 1, and so does the bottom. So I want us to notice that there's an I squared here and an I squared there. So we can replace that. So the top will be negative 6i plus 10 times negative 1, and the bottom will be 9. The middle term's canceled, and then there is a negative 25 times negative 1. So I'm replacing that I squared with a negative 1. From here, let's just clean up the top a little bit. So we have 6i minus 10 if I multiply the negative 1 with the 10. These two, if I multiply, I get positive 25. And notice there's no more negative numbers in the bottom, which is kind of nice. So I'm really left with 6i minus 10. The top I can't simplify, but 9 plus 25 gives us 34. So now the bottom, I have a real number, and I can actually divide by 34 if I wanted to. So I'll keep my answer like this. I've basically simplified the top, and I've simplified the bottom as best as I can. So at this point, I'll just leave my answer like this. So make sure you simplify the top and the bottom. All right, let's do one more of these just to make sure that we understand what's happening. So when it comes to division, I always want to take the bottom and find the conjugate. So the conjugate is going to be 1 plus I. All I'm doing is switching the sign. And I'm going to multiply the bottom by its conjugate. But anytime I multiply the bottom by its conjugate, I have to multiply the top by the conjugate. and the same conjugate. And so what I'm doing is I want to multiply the bottom by the conjugate to get rid of the i's in the denominator. I don't want to have i's in the denominator because it's impossible to divide by an imaginary number. So now here I'm going to try to FOIL. So I'm going to put some parentheses around to make this a little bit easier for me to organize my thoughts. So in the top I have 2 times 1, which is 2. 2 times I, which is positive 2i. I times 1 is positive 1i. I times I is I squared. And then for the bottom, I have 1 times 1, which is 1. 1 times I, which is positive 1i. And then I times 1 is negative I. So they both have a 1 in front. So you don't need to write the 1, but I'll just go ahead and write the 1. Negative I times positive I gives me negative I squared. 2 i's make a squared when I multiply. And so from here, let's see if we can change anything or cancel anything. So the middle terms on the bottoms cancel because they're opposite signs, but both a 1 in front. So the i's cancel on the bottom, which is what we want. We also notice that maybe the top here, we can combine these two since they're both i's, and we can change the I squared to a negative 1. So the top really is a 2i plus 1i gives me 3i, and then the I squared changes into a negative 1. The bottom we have a 1 that's left over, these two canceled, and we have a negative I squared, so that's a negative 1. So I can combine these two. 2 minus 1 is 1 plus 3i. The bottom becomes a plus sign. 2 negatives make a plus sign, so 2 plus 1, or 1 plus 2, 1 plus 2 is 2. And there we have it. So I have officially learned how to multiply, add, and subtract with imaginary numbers, and even divide with imaginary numbers. Turns out with division, you just are actually doing multiplication, and you're multiplying by conjugates in order to be able to simplify with imaginary numbers. And that is it for this video. Down below are some practice problems for you guys to try out. So if you guys want those bonus points and extra practice, feel free to try out the next page. All right, that's it. Bye, guys.